So today's presentation is about the advantages in the use of hyperspectral cameras. Some of my colleagues have already talked about this topic. I will try to speak about other interesting things about this technology. Hyperspectral cameras are used to capture and process very large number of wavelengths. I'm going to enter a little bit about how this works. And as you can see, for example, in this image, we can divide them into different sub-images, so we can obtain the wavelength of each of them. The power of hyperspectral is that we can see at the end as humans, because we can see invisible from 38 nanometers to 700 nanometers. But we have the advantage that we can see in other wavelengths, like for example a goldfish that see in infrared from 700 nanometers to 1000, or bumblebees that they see in ultraviolet from 10 nanometers to 380 nanometers. So we have the whole range. The difference with other image technologies that can be perfectly useful for the different applications. We have to select the one we need, not more. We have, for example, the more basic, that would be the binary images. They are two numbers, zeros and ones, very simple. Then we have the next level, would be the grayscale images, in which we have 255 different numbers scale. And it can be useful to detect some different contours, etc. And then we will pass to the color images, in which we already have three channels. We have the red, green, and blue. And of course, it can give us more precision, color information, etc. The next level would be the multispectral images and the hyperspectral images. The difference between them would be that the multispectral gives information about 2 to 10 bands in the complete electromagnetic wavelength, and the hyperspectral gives us hundreds of bands. So we have much more information coming from that. We can see, for example, this satellite image, in which in the right side we can see more information at the end about the composition. When I first met this technology some years ago, I feel amazed about it because, for example, we are able to detect differences even in a closed packaging. This is from pharma, but could be applied also to the food industry. And even if the packaging is closed, we are able to see the composition differences, and even if the compositions are small. We are able to detect, for example, 1 milligram difference in the composition in a gram of sample. So really precise and interesting output from this information. And now we are going to see how which are the specific applications. The first one is to find inner foreign elements in the product. Some of my colleagues have also talked about it. For example, in this line that was for producing salads, they wanted to detect different inorganic, such as, for example, plastics, rest of plastic, and stones. And we installed their system that was able to detect those differences. This is more or less simple, okay? And if we go to the application that is on the right, this is a bit more difficult, is that we are able also to detect differences between organic. So we can detect a bug or a worm into that salad. For example, it's a bit more because you need better calibration because the wavelengths are near between them than, for example, detecting an inorganic from an organic. Then another very interesting application is to measure the composition and nutritional elements in the food. This can be used, as you can see in the image, for example, to detect where is the grease, that would be the pink areas, and where is the protein, and which are also the percentage, not only the presence, but we can see how are the percentages. This can also be used, for example, in the case of hamburgers, to detect if the amounts that are published on the packaging are real or not, and if the supplier chain is giving you a good product at the end, or the one that you are purchasing. Then we have another application that is to control the process. Mainly it's used for baking, because we can see, for example, humidity, moisture, different parameters that at the end change while the food is being cooked. So we can also control that with a hyperspectral camera. And the last two applications is, first one is the seal inspection and contamination. This is very important, for example, for the meat industry, as we can control if the shield has been correct, and also if there is some small rest of different plastics or any other foreign element. We can see also with the hyperspectral camera, and the most important that we can see it in line, because those lines are usually quite quick. And finally, the last one is also related with the bakery one, is that we are able to monitor moisture. We can see the development of the water, etc., over the different food pieces using this technology. So at the end, which are the main advantages, or what can offer us hyperspectral cameras? We can see an improvement of quality and safety, mainly for the customers. And it's a no-destructive and no-contact technology, so it is very easy to handle on the factory by the operator, and it avoids other technologies that contact, etc., that were used in the past. So it has those so big advantages. And being no-destructive is also important, because in the food industry, what is usually done, you take some food piece and then you analyze in the laboratory the nutritional content or whatever, and but those pieces eliminated, and you cannot use anymore, and you can only sample one or two or whatever. But in this case, you can make all the production and you are not destroying or touching the sample. And that's all from my side. I hope you have find it interesting, and I will be happy to answer your questions.
Okay. Thank you, Elena. Thank you very much for the clarity too, and for the complementarity with the other technologies presented, and for the examples. Let's go with the questions. We have first one from Da Silva. Which nutritional properties with which precision can be detected, and in which kind of food?
Okay, for example, in the meat example that we did, we were able to detect grease, the lipids content, the proteins, and the humidity was the three parameters that were interesting for our customer. And the precision, it was around 2-3%, but each food or each piece is a little bit different, so we should study your specific case, but there are more or less the ranges.
Okay, next question from S. Cool. In most applications, is the hyperspectral camera used for the proof of concept, and then is the multispectral used in implementation in practice?
Yes, in some cases, we start with a demo with the hyperspectral to define the wavelength in which we need, or the range of wavelengths in which we need to work, and then later it can be used only with a multispectral, and in other cases it is needed the hyperspectral for the final applications. We have had both cases in the real applications.
Okay. Next question is from Juan Maldonado. When working with eggs, how can we detect a very small piece of cáscara de huevo, is eggshell like half of a rice size in the dough?
Okay, I guess he's asking about the minimum size of detection or something like that. The range depends a little bit on the wavelength that we are using and the application. But in some cases, we have to go down to 1 millimeter. But we can, I will put my email later so we can speak more in depth about the case.
Okay, from Eraser, what is the price range for the hyperspectral cameras?
Okay, here big range could go from 20,000 euros up to 100,000 for some more complicated applications.
Okay, Rafael Lopez, would it be possible to detect bodies with low density, for example, insects, parts of insects, in the trees, leaves in vegetables?
Mm-hmm. Yeah, that they are not in the surface. It depends how high they are. In those kind of applications, what we ask and what it is usually needed is that the leaves are as flat as possible, so the wavelength can penetrate. You have seen, for example, the blister. That distance is okay. So if the back would be like 1 centimeter below or something like that, I think we could see. Of course, we need to test. But if it is farther, if for example a big tank, it will not be possible. Then you would need another technology like the X-ray, for example. That my colleague was commenting.
Okay. Next question. How reliable is the quantitative measurements of composition? This is the first question. And the second one, hyperspectral is operating in reflectance configuration, and that limits penetration. Are you aware of some system operating in transmittance?
Okay, about the first question, reliability depends on the calibration mainly. Of course, depends on the price of the equipment and the specific material that we are studying. We can speak in a safe way that 5% would be achieved by all the equipment, and we can make it lower with more calibration, higher equipment, etc. And about the second question, I should ask my colleagues that are more experts and that have made more the laboratory applications. I can check with them.
Okay. Last question, because there are many others, but we will put you in contact. Last question comes from Miriam Marchena. Hello, Elena. I would like to ask you if you can get information about the quality or freshness of the food inside the package. Could you specify which aspects can you detect? Slide 8. She's talking about the slide 8 of your presentation.
Okay. Yeah. Here, for example, first we need to detect, to define freshness. For example, what would it mean for that company? For example, we could measure the water content. It's usually a freshness parameter. Also, the fibers breakage. So the fresher, the more whole and the more whole that the fiber should be, that could be also measured, for example.
Okay, thank you. We have 3 more questions from Ferran, I think it's Maria Jose Saiz and Kevin Shadler. Please share your email through the chat. Anyway, we will try to connect you, okay?
Okay, thank you very much.
Thank you, Elena.